Alright, this lesson is on quadratic functions. Remember that a quadratic function, the standard form is y equals ax squared plus bx plus c, where a, b, and c are called the coefficients, and a can never be equal to 0. Because if a was 0, then we wouldn't have an x squared term. The graph of every quadratic function is a U-shaped graph, which is called a parabola. Each graph either has a maximum or a minimum point, which we call the vertex. Right here would be a minimum because it's the lowest point on the graph. If our graph was reversed, it would be a maximum. So in other words, a regular shape U is always a minimum. An upside down U would be a maximum. There is always a line of symmetry, which will divide the graph into two equal halves. On the next slide, we'll talk about what it's actually called. But a parabola is symmetric, which means you can fold it into two equal halves. We call this in math the axis of symmetry. It's the line that divides the parabola into two matching halves. We need to know this in order to find the point of the vertex. So there's a formula to find the axis of symmetry. It's a vertical line, so it's an x equals equation. So it's x equals negative b over 2a. You take your coefficient for b and divide it by 2 times your a coefficient. We'll do some examples later. The vertex, again, is the highest or lowest point of the parabola, and we either call it a maximum or a minimum. To find the vertex, you want to plug in the x value from your axis of symmetry formula, and then you find the y value by plugging in the x into the original equation. So your vertex is always a coordinate of x and y. Other vocabulary is you will have a y-intercept because we're talking about a graph. This is where your graph crosses the y-axis, and you'll just find whatever that point is. Remember, the y-intercept is when x equals 0. Your x-intercept is where the graph crosses the x-axis. Now, in most cases, you're going to have more than one x-intercept because it's going to cross the x-axis twice. However, there are some cases when it crosses once, and we'll look at those examples soon. Right now, we only want to focus on looking where the graph crosses the x-axis by looking at the graph. There are other methods to finding the x-intercepts that we'll talk about later. So here's an example. We have y equals x squared. It's an x squared term or x squared equation, which means it's quadratic. My a is 1 because it's nothing in front of x squared, so remember that's a coefficient of 1. I don't have an x term, so b is 0, and I don't have a constant, so c is 0. It's a minimum because if I were to draw the graph of this equation, it is an upward shaped U, and the vertex point is at 0. The axis of symmetry is whatever the x is for the vertex point, so x equals 0. Now, certain things happen when we change the value of a and b. When a is positive, our graph is going to be downward. When a is negative, our graph is going to be upward. When c is positive, our graph moves up. And when c is negative, our graph will move down. How does b affect our graph? I'm not going to play with that gizmo.